Hello everyone, continuing on differentiation. In this session, we're going to be looking at some basic differentiation rules and finally the applications, which is the rates of change. So usual, I always talk about the things we have done earlier and what are we going to do in this session. So previously we talked about definition of a derivative of a function and how to find the derivative using the limit process. We also looked at the relationship between differentiability and continuity. In this lecture, we're going to look at various rules of differentials, a constant, power, constant multiple, sum and difference rules. Then also find the derivatives of sine and cosine functions, and finally the application of derivatives. In here, the best part is we're going to look at those rules which will help us to find the derivatives of functions without the direct use of limit definition. So let's start with the rules. The first one is the constant rule. The derivative of a constant function is 0, where c is any real number. That is the differential d dx, that's how we normally write, if you remember, of c is 0. Now remember, we're saying derivative of a constant function. So let's look from a graphical point of view, a constant function. But this is a constant function fx equals c. The graph of a constant function is a horizontal line. And we all know that the slope of a horizontal line is 0. And what is the meaning of a slope of a line? Remember that slope of a tangent line is nothing but the derivative of a function at that point. So any point we take on this horizontal line, the derivative of the function is going to be 0. And that's what is the simplest rule, that is the derivative of a constant function is 0. So let's look at examples. So like derivative of 7, 0. Pi, remember pi is a constant, it's a 3.14 and then we keep on continuing. Again, it's a constant value, a 0. If you remember the trig functions here, sine of pi half, which we know is sine 90, which is 1. So basically, the differential of sine pi half, which is actually the differential of 1, is a 0. Let's look at some more constant functions. If y is 3, clearly differential is 0. If it's 1/8, again differential is 0. S of t, it's cosine pi. Now if you remember, cosine pi is what? It's -1. So the differential of s of t, which is using different notations, I'm trying to use different notations here just to get you more comfortable with the way how we write differentials. So s prime of t again is 0. Y is pi square. Remember, we just said differential of pi was 0, so pi square again would be 0 because pi square again is a number. So if you notice, when I'm writing over here y dy by dx, I could have written this as y prime to fx. I could have written as f prime of x or df of x over dx. It's just various notation forms I'm writing over here. Whichever makes you comfortable, go ahead and pick up that. Now we're going to start with power rule. Now power rule is a very, very powerful rule, as the name suggests, power. This is the basis of our differential rules, I would say. Literally everything we'll do in differentials will somehow into this form or the other. This form up here. So what's a power rule? If n is a rational number, then the function fx equals x to the power n is differentiable, and we write the differential d dx of xn as n times x to the power n minus 1. This is very, very important. It's like the base of our foundation for our differential rules. So if my f is differentiable at x equal to 0, then n must be a number such that x to the power n minus 1 is defined on an interval containing 0. because remember, we cannot have functions with the denominator to be 0. So those are the things it is keeping in mind. Just to keep in the back of your mind, that's why this line has been written. But at this point, the most important thing for us is to remember the power rule. And we're going to practice and practice a lot. Okay, so what basically the power rule is, if you have x to a power something, a rational number, then the differential of that is you take the n from the top, put it in the front of x, and x should be now raised to the power n minus 1. So let's start with examples. Differential ddx of x cubed. Now remember, n is 3. So what does that mean? 3 comes in the front, x, and then you subtract from 3, 1. So 3 minus 1. What do we get? 3x squared. Okay, let's look at another example. ddx of x. That means now x here has power 1. So the 1 comes in the front times x. Now from 1, remember your n is 1 here, minus 1. What do we see? It's 1 times x to the power 0. Now remember, anything to the power 0 is 1. So it's 1 times 1. The final answer is 1. Okay, remember n is a rational number. So if we take differential of x to the power minus 4, that means my n is now a negative 4. So according to the rules, it's going to be minus 4 times x to the power minus 4 minus 1. What do we get? Minus 4 x to the power minus 5. That's it. Let the answer be like here. Now we're going to practice a lot different kind of functions. So first one is y equals square root of x. Now keep in mind, when we apply the power rule, guys, this is important. I'm going to write the power rule here. If my y is x to the power n, then y prime, that is the differential of y, is n times x to the power n minus 1. Okay? Notice the square root of x. It is not in the form as the power rule is defined. So first of all, we have to change the given function in the proper format before we can apply the differential. So we all know we can change this radical root into an exponent form here. So it will be x to the power 1/2. And that really matches with the power rule notation. Okay, so y is now x to the power 1/2. So what is dy by dx? So your n is now 1/2. So it will be 1/2 in the front times x. And you subtract from 1/2 1. So it's 1/2 minus 1. What do we get? 1/2 x to the power 1/2 minus 1 is what? Negative 1/2. Or you can write like this, this can be written as 1/2. X can be brought in the denominator if you want like that. Different forms just to practice algebra at this point. So this can be written as 1 to square root of x. Okay. Now let's look at the function. The next one, fx is 1 over x squared. Now once again, this is not in the proper form for our power rule to be applied. Now the x is in the denominator. You have to get the x in the numerator. Now again, we're going to use our exponent properties. When x is taken in the from the denominator to the numerator, we all know that we change the sign of the exponent. So it's now going to become minus 2. Now this function fx is format which power rule is happy with. So now take the differential of this f prime of x is what? Negative 2x, negative 2, negative 1, which gives us negative 2x, negative 3. You can leave it like that, guys. I'm not looking for positive exponents. That was your algebra days. Here, that's more than enough. More important here is to remember the rules. Okay, let's look at the next function, s of t, which is t to the power 1/8. Now here, we are having a rational number here again. as a power. So when we want to apply the power rule, it's again in the proper format. So s prime of t is going to be what? 1 over 8 t to the power 1 over 8 minus 1. Now, which is this? 1 over 8 t. Now remember, neither common denominator, it's 8. It's going to be 1 minus 8. So it's 1 over 8 t minus 7 over 8. We're done. Okay, now let's look at the last example in this slide. Y is cube root of x to the power 5. This is not in the format we're looking at, okay? So we're going to change this cube root using the exponent property. So it's x to the power 5 raised to the power 1/3. Once again, we'll apply the properties, which is x. You're going to multiply 5. Okay, let me make the 5 nicer looking. So what is it? So this is x. It's now going to be 5/3. Now when I want to take the differential y prime, it's going to be 5/3 x 5/3 minus 1, which is going to be what? 5/3 times x. Now 3 is the common denominator. 5 minus 3. So your final answer is 5/3 x 2/3. Okay. Let's look at another rule, which is called the constant multiple rule. It says if a function is differentiable and c is a real number, then c times f is also differentiable. Okay guys, there's a typo. This should be a c. So differential of c times fx. Now remember, c is a constant. It simply means if you're taking a constant multiplied to a function differential, then you just basically take the c out and take the differential of the function. So it's c times f prime of x, or c times d dx of fx. So let's look at this one. d dx, or differential of 3x to the power minus 4. Now remember, 3 is a constant. We take the differential out and take the 3 out and take the differential of x to the power minus 4. So I think we've done that before. It's going to be 3 times minus 4, x to the power minus 4 minus 1. So it's going to be now negative 12 x to the power minus 5. So this next problem, differential of the function 4 to the times square root of x. Now remember, this square root of x is not looking like the way we saw earlier. And this is exactly what we have done before. So that's what same we're going to do down. And now we're going to write this as first 4x to the power half. Now remember, this simply means you take the 4 out and you're taking the differential of x to the power half. So your final, now take the differential, 4 times half x to the power half minus 1. So what is it? So 4 and 2, there's a common multiple, so you can take, common multiple can be taken out. So it's going to be 2x minus half. So you can leave the answer as it is. Okay, let's do some more examples. Now, if you're given y to be negative 15 cube root of x. So differential of this is basically, now first of all, before I apply the differential, remember cube root of x has to be written in a proper form, negative 15 x to the power 1/3. So the differential of this is what? So basically it means negative 15 x to the power 1/3, you're taking the differentials. I'm going to make my life simple. You can write like this, or you can write this as d dx of minus 15 x to the power 1/3. Now remember, it's a constant multiplied to a function. You can simply take the negative 15 outside and apply the differential on the cube root of x. Notice the way I'm writing is making my life simple. So instead of writing d dx all the time, I'll take the function, put it in parentheses, and a differential sign. That is prime, we normally call that. So it's going to be negative 15 times 1/3 x to the power 1/3 minus 1, which will give us 3 times 5 goes into 15, so you got a negative 5, so 3 times 5, remember, it's 15, x minus 2/3. Okay, let's look at the next problem. 1 over 7x to the power negative 5. So this you have to remember it, write it in the form. When you're applying, keep this in mind. Every time you start, if it's the first time you're doing it, keep this expression in front. Y equals x to the power n. So y prime is n x n minus 1. Just remember that. So first of all, I'm going to write it in the proper form. This will be 1 over 7. It's a constant. So basically, constant always pops out. Now, x to the power minus 5, when you take it in the numerator, this expression, x to the power minus 5 becomes x to the 5. So it's f prime of x. So this is basically saying we're taking the differential of 1 over 7 x to the 5 differential, which is going to be 1 over 7 differential of x to the power 5, which is basically 1 over 7 times 5, x 5 minus 1 is a 4. So now you should be getting comfortable. You don't have to write minus 1 all the time. You can just start doing it in your head. So it's 5, 7, x to the power 4. Okay, the next one is 12 times t to the power 1/8. We have already done this differential of t to the power 1/8. So it's basically 12 times t to the power 1/8 differential So it's 12 times 1/8, and we already know the differential of t to the power 1/8 is what? Negative 7/8. So your final answer, the 3 is common between 2 or 4. 4 can easily cancel 8 and 12. So what we'll get is 3 over 4 t to the power, 3 over 2, guys, sorry. So this 4 goes 2 times, 4 goes 3 times. T to the power negative 7/8. Okay, what we have learned so far, guys, are 3 different rules. The constant rule, the power rule, which is the most powerful rule, and the constant multiple rule. The constant multiple rule is the one which is very, very important. So keep that in mind. The notation is very important. Notice I have done so many different kind of problems. So I want you to keep every time you start these problems on differential, if it's the first time you're doing it, make sure you keep this power rule in front of you. Okay, now time for you to practice. So I have got these 10 problems for guys you to practice with. Okay, now I am going to start with sum and difference rules. Basically, we are going to add these things together. So let's start with that. The sum and difference rules. The sum or difference of two differentiable functions, it's itself differentiable. In other words, if I'm taking the differential of fx plus gx, it is the same as I'm taking individual differentials, then adding them. Or if there's a negative sign, differential of fx minus gx, I'm taking the take their individual differentiable functions and put a minus. So let's look at this one. Differential of 3x cubed plus square root of x minus 9. So what does that mean? It means take the differential of 3x cubed plus the differential of square root of x plus the differential of minus 9. Now, We have already done, so 3x cubed. So I'm going to go upwards. There's much more space here. So this is equal to, this is differential is what? 3 times x squared. We already know the differential of square root of x, which we have done earlier, is half x minus half, and differential of a constant is a 0. So then the final answer is what? 9x squared plus half x minus half to the power minus half. Now, guys, keep one thing in mind, that when you're taking differentials of different expressions, you don't have to write down differential of this plus this plus this. You know, you practice so many times that you just simply start writing the answers. Okay, let's do some more practice problems, on examples, and then you will guys be doing some practice problems. Okay, so when I want to find the differential of these three functions here, the first one is 5 times cube root of x plus pi x. Now remember, before we apply the differentials, make sure you write it in the proper form. So it is 5x to the power 1/3 plus pi. Remember, pi is a constant. So if I take the differential of this function, which is y, so it's basically it will be 5x 1/3 differential plus pi x differential. Now the constant, 5 is a constant in the first expression, so it's 5x to the power 1/3 differential, and pi is a constant, and x to the power differential. Now we know the differential of this is what? X to the power is 5/3, because x times, you take the 1/3 out, and 1/3 minus 1 is minus 2/3, and we have done that before, plus pi. Now remember the differential of x, that was the very first kind of example we did in the power rule. It is 1. Okay, as usual, whenever you're doing the problems, I'm sorry I forgot that, keep this power rule right in front of you when you're doing it. That way you will not make a mistake. Okay, let's look at the next problem. Fx is 1 over x to the power minus 5, negative 2x to the power minus 9. So before I start the differential, I'm going to write it in the proper form. This is x to the power 5 minus 2x to the power negative 9. So when you take the differential, it's x to the power 5 differential minus 2 x to the power minus 9. Then you know this is the differential. This is sum of two functions. So taking the differential gives, for the first expression, 5x4, then minus 2 is a constant, remember, then minus 9 x to the power minus 9 minus 1 minus 10. Clean it up. So your final answer is 5x to the 4 plus 18 x to the power negative 10. Okay, next one. Before we start, notice we always look at the terms which are given. 12 times t to the power 112 minus sine pi by 2t. Now remember, sine pi by 2 is what? It's 1. So basically the expression is simply 12 t to the power 112 minus t. So whenever you're given problems, guys, if you can simplify it before you start the differential, making your life more easier. Okay, so what's the differential of s prime of t? It is 12 t to the power half. Okay, I'm going to use a different color pen here. Okay, so this was going to be 12 times t to the power 1 over 12 differential negative t differential. So this is basically 12 times 1 over, remember 12 is a constant, you basically pull it out, then you apply the differential of t to the power 112, t times 112 times t to the power 112 minus 1, and negative t. So it's basically 1 times t, 1 minus 1. Okay, so what are we getting here now? So the 12 and the 12 cancel out in the first expression. You're left with t, 112 minus 1. I'll let you do the algebra. It's negative 11 12s. And t to the power 0 is basically, it's minus 1. Because t to the power 0 is 1. Okay, so we have learned the sum and difference, so it's time for you guys to practice. Thank you.